Thank you. I'm Laura Thompson, and I'll be covering the data pillar termed data integrity. So to get started, the purpose of this data pillar is growers need a strong understanding of farm data integrity or data quality. So more specifically, it's important to understand how errors during data collection and processing may affect the decision-making process. And it's important to understand the methods we have available for improving data quality. This will ultimately result in growers having more confidence in the data that they're collecting and the results of future analyses. And it'll allow them to have more confidence in decisions that they're making based on the data that they're collecting on their farms. So why is data integrity or quality important? Well, first of all, there are errors that are inherent in nearly every sensor or system of sensors that are used in precision agriculture. These errors can propagate through future analysis and affect prescriptions and other analysis results. When we're looking at doing on-farm research, proper experimental design is critical to help minimize errors that can occur during an on-farm research trial. And to have maximum confidence in data-driven decisions, proper error correction and analyses are critical. So let's take a look at an example. Here we have yield monitor data. Yield monitors utilize a suite of sensors to estimate yield, and errors can originate from sensors themselves or from the method of estimating area harvested. So on the top, you see a portion of the yield monitor map that is raw yield data points directly from the combine monitor. You can see that there are many data points that are red where there was a yield of 0 bushels per acre recorded. This is where the monitor was still recording yield data, but the combine was not harvesting grain and occurred at the end of the rows. On the bottom image, you can see the same yield map, but with these erroneous data points removed. It's important to clean yield data before data is used further. So in this case, we used a program called USDA Yield Editor, which is a free software to clean the data. Often yield data is used to create a prescription layer, such as a nitrogen application prescription. So in this case, we've taken that data and developed a nitrogen prescription using a university nitrogen rate equation, which utilizes yield as one component in the equation. So as you can see, the errors in the yield data have propagated and affected the prescription that we've generated. In this case, on the top, you can see that wherever there were 0 yield values, we have improperly lowered our nitrogen recommendation. There are areas in the field which are receiving 75 pounds less nitrogen than would be recommended when we're using the clean yield data. So this is just one example of the importance of yield data quality. Many growers also are utilizing on-farm research as a source of information for their farming operation. And this is a great way to get information that is specific to your farm and growing environment. However, to get the most out of your on-farm research efforts and have confidence in your results, it's important to follow proper experimental design guidelines. So in this example, the grower was interested in evaluating his planting population. You can see that we have 3 seeding treatments, 32,000, 36,000, and 40,000 seeds per acre, and each of these treatments has been arranged into blocks where each block contains each treatment. We've then replicated those blocks 6 times across the field, and we've randomized the order that the rates occur within each of the blocks. So this helps us to reduce and account for the effects of field variability. When evaluating the results of an on-farm research study, it's great to include some economical and statistical aspects to help understand the data. So in this case, we're evaluating that economic response for the seeding rates we just looked at. We can use statistical analysis to help us determine the confidence in the results. So in this case, if you look at the graph there on the right, looking at partial profit for each of those 3 seeding rates, we can see that if we had just looked at the 3rd replication and placed the trial there, we would have concluded that the 36,000 seeding rate was most economical. However, since we had 6 replications, we can see from that chart and the table below that most of the time, 4 out of 6 replications, the rate of 32,000 seeds per acre was the most economical. So our takeaways here: data quality must be considered to ensure confidence in decisions made on the farm. Visualizing data sets or using automated tools can help us reduce those errors in the data we're collecting. When we're looking at doing on-farm research, using proper experimental trial designs and planning is critical to get quality information. And then finally, using statistical analysis of randomized replicated data is key for making solid data-driven decisions on the farm. So now we'd like to turn to Slido and pose a question here. Do you perform quality control and cleaning of your yield data prior to using it to make management decisions?